Welcome. In this video, we want to look at water power. And our emphasis on hydroelectric power generation, wave power generation, and tidal power generation. Let's look at how we use water power to generate electricity. It's what we want to look at in the course of this class. So, the Earth has a huge amount of water which cover about 3/4 of the planet. And the water power has been exploited by mankind for thousands of years. Any challenge? Okay. We derive mechanical power from this water in various ways. And this includes, we use water power for hydroelectric power generation, ocean wave power generation, and tidal power generation. So we shall be looking at how we use hydroelectric power to generate electricity, ocean wave power to generate electricity, and tidal power to generate electricity. What is hydroelectric power? Hydropower or hydroelectric power is the energy obtained from the potential energy of water or moving water. The moving water has a potential energy. So this energy can be directly harnessed to rotate the shaft of a hydraulic turbine for mechanical work. And by hydroelectric power, we mean power that is being obtained from water that falls through a vertical distance from a reservoir to drive a turbine. So hydroelectric power is a clean energy. It's one of the renewable energy sources. So that is harnessed, that we use to harness the potential of water located at high altitude in mountain basin, which when falling act as a turbine producing electricity. So hydroelectric is by far the most established and widely used renewable energy sources for electricity generation. And it accounts for about 20% of the world electricity generation. We use other renewable energy sources like wind, like biomass, like solar. However, hydropower accounts for about 20% of world electricity supply. Let's look at hydroelectric power generation. Hydropower plant uses water to generate electricity. The plants are usually located on or near a water source, and the energy available from the moving water depends on both the volume of the water flow and the change in elevation. We shall be looking at all that as we make progress. The greater the flow and the higher the elevation, the more the electricity that can be generated. So at the plane level, water flows through a pipe and then spin the blade in a turbine, which in turn spin a generator that automatically produces electricity. We shall soon be looking at how electricity is generated using hydroelectric power. This is what we are saying. This is a dam. This is also another dam. As we can see, water is flowing at an elevation, and from the dam, let's look at this setup. This is how water is generated as the water flows from the dam through a penstock into a turbine. This is the turbine. It spins the blade of the turbine, and this turbine is connected to a generator. This is the generator, and through that, electricity is generated. The electricity generated here is a transformer, a step-up transformer. So the electricity that's generated is being stepped up for onward transmission. As we can see here, these are transmission lines. So this is how we use hydroelectric power to generate electricity. First of all, we have a dam, water falling from the dam at an elevation. Here is a dam. So water flows through the opening, which we call penstock, into the turbine. And in the turbine, it spins the turbine connected to a generator. and in the process, electricity is being produced. And a step-up transformer stepped the voltage being produced for transmission, and the electricity produced is being transmitted. So this is the setup of a hydroelectric power generation. Okay, let's look at the advantages and disadvantages of hydroelectric power. Let's start with the advantages. One of the advantages is low pollution. Hydroelectric plants produce minimal pollution, reduces greenhouse gas emission, unlike fossil fuel and other sources of energy. Also, low cost. Once hydroelectric power plant is built, it runs for years with low maintenance. Another advantage is that it is a renewable energy. So hydroelectric power is a renewable energy source, ensuring long-term sustainability, unlike other energy sources like fossil fuel that is not sustainable and may finish with time. Okay, let's look at the disadvantages. One of it is high cost. Hydroelectric plants require significant initial investment for construction of the dam, as we have seen, and also the turbine and the generator. Then also environmental impact. Hydroelectric dam can alter river ecosystem and affect aquatic life. It's another disadvantage. Then drought vulnerability. Hydroelectric power generation, it depends on water availability, making it vulnerable to drought. If there is no water in the dam, then the turbine will not be able to turn, let alone producing electricity. So these are just the advantages and disadvantages of hydroelectric power. Next, we want to look at wave power. Anyone swimming in the sea feels the power of the wave, especially if they are drawn too far away from the coastline. So indeed, ocean waves has the potential to deliver huge amount of energy. So let's look at how we use ocean wave. So wave power is the transport of energy by ocean surface waves and the capture of that energy to do useful work. For example, we use wave power for electricity generation. We shall be looking at how it is done by converting wave energy into electrical energy. We equally use wave energy to remove salt from water. Then we use it in water pumping, employing wave energy to move water into reservoir. So these are some of the uses of ocean waves for electricity generation, for water desalination, and also for water pumping. These are the uses of ocean wave. Let's look at the advantages. Ocean wave is a renewable energy. Waves are naturally replenishing energy source. So one of the advantages of ocean wave is that it is a renewable energy. Also, global availability. Ocean waves are present in ocean worldwide. Wherever you have an ocean, there are ocean waves. And another advantage is predictability. Waves are more predictable than other renewable energy. Other renewable energy like the wind is difficult to predict, unlike while ocean wave is easy to predict. So these are some of the advantages of wave energy. Let's look at because of the advantages, there have been many schemes to harvest the power of wave ocean, and a number of these schemes have been tried. So, however, wave power has yet to contribute a significant amount of energy to world demand, even though we are seeing the advantages that it can be used as a renewable energy. Let's look, there are some challenges. Let's look at the main reason why ocean wave has not properly been used in generation of electricity. One of it is the hostile environment. Ocean's harsh condition pose risk to the equipment that will be used, and also those to operate the equipment, because ocean environment is hostile. Then another disadvantage large wave. We are talking about the sea, we are talking about the ocean. So the extreme wave can damage wave energy devices. The device that will be employed in the generation of electricity, the large wave has the capacity to damage it. Then salt water corrosion, because sea water they are salty, ocean water they are salty. So salt water degrades mechanical component over time. The equipment to be used, the tendency for them to rust with time. So these are some of the disadvantages of wave power in electricity generation. So wave power, however, wave power is used to produce electricity. And the machinery used to exploit wave power is generally known as wave energy converter. Despite the disadvantages, we still employ wave power in electricity generation. However, much plant have not really been installed. The energy provided is most often used in desalination plants, power plant, and water pump. Energy output is determined by wave height, wave speed, wavelength, and water density. These are some of the factors to be considered while using wave power in electricity generation. The wave height, the wave speed, the wavelength, and the water density. So to date, there are only a handful of experimental wave generator plants in operation around the world because of the limitation mentioned earlier. So this a wave power plant that is used in generation of electricity. Okay, let's look at tidal power. It's another water power that we use in electricity generation. The daily rising and falling of the sea level is a familiar sight, and those close to a coastline, the difference in height between low tide and high tide, called the range, can be considerably severe meter or more. Clearly, this involves huge changes in the potential energy of the water. If the water at high tide is trapped behind a dam or barrier, this potential energy can be harnessed in an analog way to a hydroelectric plant. So we can use tidal power in electricity generation. However, tidal motion are complicated, and so they are difficult to predict, unlike ocean wave that we have earlier looked at. However, there are some advantages of tidal power. One of it is that it is a renewable energy source, like the ocean wave and the hydroelectric. Another one, high energy delivery. Because of the potential, it can supply significant amount of energy. Then the other one, global site. Numerous sites worldwide offer substantial tidal energy. So by this, it can be employed in energy generation. So these are some of the advantages of tidal waves. Let's look at the challenges or the disadvantages. One of it is high construction cost. Building of tidal power plant is very, very costly. Another limitation is that it requires specific topography. So limited suitable location there are a limited location because of the requirement of the topography to be employed in tidal power generation. Another limitation is limited site available, restricted potential power generation. The site requires may be limited. It's another disadvantages. Then the last one here is ecological impact. It has large ecological impact on the local environment. So these are some of the challenges involved in using tidal power in electricity generation. So how do we harness tidal power? There are two main ways in which it can be harnessed. One is to exploit the potential energy of water at high tide, and this is called tidal range power. The other one is to exploit the kinetic energy of tidal water that flows through narrow channel, and this one is called tidal current power. So Tidal energy is produced through the use of tidal energy generator. That is what we use to generate electricity using tidal power. These large underwater turbines are placed in areas with high tidal movement and are designate to capture the kinetic motion of the ebbing and surging of ocean tides in order to produce electricity. So tidal power has great potential for future power and electricity generation because of the massive size of the ocean. So let's look at the tidal power generation. This is the generator that is being used. This is a tidal wave moving in. Then the wave turns the turbine connected to a generator, and in the process, electricity is being produced. Though this is a tide coming into the generator, while this is a tide going out of the generator. So through this, tidal power is used to generate electricity, as we can see. So let's look at, we have talked about hydropower hydropower plant that we use in generating electricity. So let's look at hydroelectric power plant in operation.
People have been capturing the energy in moving water for thousands of years, and today it's still a powerful resource that generates clean, renewable, and affordable electricity. Hydropower technologies are one of the ways we can harness energy from moving water and convert it to electricity. Hydropower facilities use the elevation difference created by a dam or diversion structure. Water flows in one side and exits at a lower point, spinning a turbine which runs a generator and produces electricity. America has been using hydropower to generate electricity for nearly 150 years. And today, about 6% of all our electricity is generated from hydropower, and it's one of the largest sources of renewable power. So what makes hydropower renewable? It's simple: water. Water evaporates into clouds and recycles back to Earth as precipitation. The water cycle is constantly recharging and can be used to produce electricity along the way. There are several ways hydropower technologies can generate electricity. You may recognize dams like this one. This technology is called an impoundment. The impoundment stores water in a reservoir. When the water is released, it flows through and spins a turbine, turning a generator that produces electricity. Here's another technology. This is a diversion. It channels a portion of a river through a canal or pipe into a turbine and generator system. What's cool about this method is that it uses the natural flow of the river and usually doesn't require a large dam. And have a look at this. This is called pumped storage hydropower. Basically, it works like a huge battery. To charge the battery, water is pumped back up into a reservoir during periods of low energy use, often during the night when people are using fewer appliances. Then, when people need more power during the day, the water can be released to produce electricity. With how long we've been capturing energy from water, you may think there's nothing new in hydropower technology. Think again. The U.S. Department of Energy is helping to upgrade many older facilities. It is funding the research and development that will help increase the efficiency of turbines and generators, for example. Operators of neighboring hydropower facilities are also working together to optimize energy production across whole river systems instead of each dam working alone. And we can add generators or retrofit dams that were built without power, like dams used for watering crops or preventing floods. Today, there are more than 90,000 dams in the U.S., but less than 3% of these dams produce power. That means there's an opportunity to generate more clean, renewable power at dams we've already built. New technology is also making hydropower even more environmentally friendly. For example, researchers are reducing adverse impacts on fish and their natural habitats, and fish ladders like these let them swim around dams. Hydropower is an essential, reliable, and renewable source of clean energy with a rich history. And it's meeting substantial energy demands today. With new technologies, it will be even more efficient and have greater production capacity, powering U.S. homes and businesses for centuries to come.